Alright, 8th graders, today we're talking about comparing linear, exponential, and quadratic functions. And so you're going to have to tell the difference between each one of those. We'll start with the simplest and the one we have the most experience with, which is a linear function. And a linear function, of course, is a line. It says so right in the name. So it's going to be a straight line, and its equation is y equals mx plus b. An exponential function has an exponent in it, and it is generally a curve where something is approaching 0 or approaching a number and never quite gets there, but it's a curve, and the equation is the form y equals a times b to the x power, where a is the initial amount and b is the growth factor. And then a quadratic function is a parabola. And it takes the form y equals ax squared plus bx plus c in its standard form. So as we go, we'll be finding the differences between linear, exponential, and quadratic. This next section says plot the points, tell whether the points represent a linear, exponential, or quadratic function. So let's take a look. I'm going to use this for graph A. So for 2, 0, 0, 0, 1, negative 1/2, and negative 2, 4. So if I graph this, it is a parabola, which makes it quadratic. I'm going to use this one for graph B. So 0, 1, 2, 4, 4, 7, negative 2, negative 2, negative 4, negative 5. And that one's clearly linear. And so graph C should be exponential. 0, 2, 2, 8. One, 4, negative 1, 1, negative 2, 1/2. So this is approaching 0, but it's never going to hit 0, which makes this exponential. So I think if you're given points, you can definitely graph it and figure out which is which, but you're not always going to be given points, and sometimes graphing isn't the path of least resistance. Sometimes graphing, we aren't able to tell through graphing exactly which type of equation we have. So here are some things that we need to know about each type of equation. A linear function is going to have you adding or subtracting as your common difference. So here to here to here to here, those are all plus ones. Here, as we jump, they're all plus twos. So the common difference, in this case we call slope, is the change in y. So the y's are changing by a positive 2 over a change in x. The x's are changing by 1. So the slope is 2. On the exponential function, we can see that we have our initial amount and then our common ratio of 2, and then our x for our exponent. In this case, the common ratio or common difference is always multiplied. So here we have addition and subtraction, here we have multiplication. So this is all increasing by 1, and this is times 2 times 2 times 2 times 2. So the common ratio is 2 in this case. And then on the quadratic function, we have x squared plus 2x minus 1. So quadratics are where things get a little bit more interesting. Those are all plus ones, but let's look at the pattern here. We have minus 1, plus 1, plus 3, plus 5. And you'll notice that there's no pattern there, but when you do look for a pattern in the second difference, you'll see that it's plus 2, and plus 2. So the second difference forms a pattern in this case. And fortunately for us, when we're looking at our equation, we look at this second difference of plus 2. We divide it by 2, and that's what equals a. So whatever this second difference is divided by 2, that's what goes in as our a value. And we're only going to be looking at equations that are ax squared here in Math 1. So the next part says tell whether a table of values represents a linear, exponential, or quadratic equation. And so we can see here we have plus 1, plus 1, plus 1, plus 1, so we're not having to worry about the x's. Here we have minus 3, minus 3, minus 3, minus 3. So when we have a common difference that's the same each time, it's linear. On the next one, again we have plus 1, plus 1, plus 1, plus 1, so we don't have to worry about that. Here we have minus 1, plus 3, plus 7, plus 11. And since there's no pattern, we want to look for the second difference, which is plus 4, plus 4, and plus 4. So this is going to be quadratic, because there's a pattern in the second difference. And then on the last one, our x's are all increasing by 1. My y's are plus 2, plus 6, plus 18, and then plus a massive number. So in this case, I look to see that it's times 3, times 3, times 3, times 3, and anytime I have a multiplication common ratio, then I know I have an exponential equation. The last thing that we're going to have to do in this section of notes is you're going to have to be able to write the equation. And we've had lots of practice writing linear. I think I'll be able to remind you quickly about exponential. The quadratic one is really the new piece, and we'll take a look at that. We're going to look at the equations that are right here from the table. So on this first one, since it's linear, and we have found that these are all plus 1s, so I'm looking for y equals mx plus b. And so I need to know my slope, and I can see it's the change in y over the change in x. So my slope is 3 over 1. And my y-intercept is when x equals 0, which is listed in my table here at 2. So y equals 3x plus 2 is my linear equation. On the next one, I have a quadratic, and this is the one, that's the new one. So let's take a look at what this one's going to look like. All we do is we look at this second difference. We see that it's 4. So we take that 4, we divide it in half, we get 2. So my equation is y equals 2x squared. And again, I said we're only looking at y equals ax squared equations, because when we add in the b and c, it becomes more difficult and more of a math 2 situation. So we're just looking at these simpler equations. And then exponential, you'll remember we take the initial amount, so that's when x equals 0. So the initial amount is 3. And we're multiplying that by our common ratio, which we found is 3, and that's just to the x power. So that's my whole equation for exponentials. So if you look at these last two, you have to tell whether it's linear, exponential, or quadratic, and then go ahead and write the equation. So go ahead and try those two for homework, and we'll go over them tomorrow. Have a great night.